Quick, graph y equals the absolute value of the quantity of 1/2 x plus 3 minus 4 by hand, two different ways. This is part of the family of functions series. You will need graph paper, or you can download this PDF and print it. Press pause as needed anytime during this video. So we first need to decide what the parent function is and its shape. Parent function is the absolute value function. It's a V shape, and this is what the parent function's graph looks like. Keep that in the back of your mind. Identify the parameters. Those are the values in the expression that affect the graph. But before we do this, we should rewrite the equation in a more usable equivalent form. For example, inside the absolute value, we're going to factor out a half. And when we do that, we get half of the quantity x plus 6. You can see when you distribute it is equivalent to this. And then also, the absolute value of a half is a half. I can bring that out front. And then, so I'm going to look at this equation here, y equals 1/2 the absolute value of the quantity x plus 6 minus 4. Those two are equivalent forms, but the second one is more usable to us. So the parameters are a half, plus 6, and minus 4. But how do they affect the graph? Well, the minus 4 shifts all points down 4. The plus 6 inside the function, inside the parentheses, so to speak, inside the absolute value, shifts all points to the left 6. And the 1/2 multiplies each y value by 1/2. Which ones do we consider first? We suggest plotting the vertex first. And so using the parameters that affect that, we go left 6 minus 6, and then down 4 minus 4. So -6 comma -4 is our vertex. We plot that first. And now we do the absolute value dance using the coefficient 1/2 to affect that dance. And we plot relative to the vertex. So instead of right one, up one, like we would on an absolute value dance, we're going to go right one, up a half because of this half factor. Instead of right 2, up 2, like we normally would, it's going to be right 2, only up 1, half the distance. Instead of right 3, up 3, right 3, up 3 halves. We suggest you do the left side. Press pause to do that, and then resume when you're ready. So on the left side, instead of left 1, up 1, left 1, up a half. Instead of left 2, up 2, left 2, up 1. And instead of left 3, up 3, left 3, up 3 halves. Connect the points to make it look like an absolute value V. The vertex is at -6, -4. The axis of symmetry is the vertical line x equals -6. You can see it's a reflection about that line on each side. And the slopes of the V actually come from that coefficient, the half. And so the slopes are either positive a half going uphill here, or -1/2 traveling downhill here. Compared to the parent function. So let's do a second way using a table. Again, I'm going to use the equivalent form to this equation. I think it makes it much easier, or work much easier. Here's our traditional absolute value table. So the plus 6 affects the x values. What it does is shifts the points to the left 6, and to accomplish that, we need to subtract 6 from each x value to get it to shift left 6. So 2 minus 6 is -4. 1 minus 6 is -5. We're going to ask you to pause, finish those three values, resume when you're ready. So we get 0 minus 6, -1 minus 6 is -7, and -2 minus 6 is -8, and that takes care of the x values. The other two parameters affect the y values. And by the order of operations, we do the multiply by 1/2 first, and then we subtract 4. So for example here, 2 times a half is 1, minus 4 is negative 3. And it shows that calculation right here. So we'll plot negative 4 comma negative 3. 1 times a half is a half. Minus 4, we'll think of a minus 4 as minus 8 halves. So that's negative 7 halves. So plot the point negative 5 comma negative 7 halves. We ask that you pause the video and finish these 3 points and plot them. Resume when you're ready. 0 times a half is 0, minus 4 is negative 4. So negative 6, negative 4. And we did the last two really up here. So we're going to get negative 7 comma negative 7 halves, or negative 3.5. And negative 8 comma negative 3. Connect the points into an absolute value v. We like to compare it to the parent function. Now you try one. Graph y equals the absolute value of the quantity 2x minus 4 minus 5, and use either method or both for the practice. Press pause to do this and resume when you're finished to check your answer. And here's your answer in green. We have both the parent function and the green function table here to help you check your answers.